Assalamu alaikum students. My name is Nida Sheikh and this year I'll be teaching you physics. As you know, science has three main branches: physics, chemistry and bio. That is biology. Let us understand what does physics mean. Physics is the study of everyday phenomena. It aims to explain these phenomena in terms of the fundamental laws of nature. Physics is the study of matter and energy and their relationship. Do you also know? Physics has many branches. Let us see few main branches of physics. Modern physics, classical mechanics, astrophysics, nuclear physics, electromagnetism, optics, and thermodynamics. So, if you recall your last year's physics topics, you must be similar to the topics light, sound, waves, motion, forces, heat. So, all these topics come under one of the branches mentioned here. So, the first topic, which is from mechanics, and that is forces. So, your chapter 1, which you're going to study this year, is chapter 1 forces. What is force? Force is a push or a pull on an object. So, if you apply a force on a body, the body will tend to move from one place to another. That means you have applied force to that body. You have two main subtopics here, and they are speed and velocity. Let us see what is the meaning of speed and what's the meaning of velocity, and are they different? If you actually speak in simple terms, speed and velocity, they are nothing but same. How fast an object moves, that is given by speed, that is also given by velocity. But then what's the difference between those two? Let us see. Speed of a body is the distance traveled by it per unit time. So whatever is the distance covered in that particular time is called as speed. Example, if a car is traveling and it has covered a distance of 50 meter in 10 minutes, then this distance divided by time will give you the speed of that car. Velocity. Let us see what's velocity. Velocity of a body is the distance traveled by it per unit time. Up till here the definition is same as that of speed. But here something else is added, and that is velocity of a body is the distance traveled by it per unit time in a given direction. So velocity needs direction. Okay? Speed doesn't require any direction. So the quantities which do not need direction, they are called as scalar quantities. That is why the second point, you will see that speed is a scalar quantity. And the quantities in which direction is essential, they are called as vector quantities. So velocity is a vector quantity. Speed, it cannot be zero, but velocity can be zero. So this was the major difference. These were the major differences between speed and velocity. Let us see the three formulae derived from the formula speed is distance upon time. So what is speed? A particular distance covered per unit time is speed. So speed is distance upon time. This diagram is called as a triangle formula. In this diagram, distance is mentioned up and speed and time are mentioned down. The line after the distance represents the division sign, and the sign between speed and time represents multiplication sign. So if you see in the first triangle, distance is colored pink, it is highlighted. So if you want to know the formula for distance from this triangle formula, so you have to color distance, or you may keep your finger on distance. So if you keep your finger on distance, you will be left with speed multiplied by time. Hence we get the first formula, and that is distance is equals to speed multiplied by time. In the second one, let's derive the formula for time. So time is highlighted in the second formula, and then what is left? Distance divided by speed is left in the triangle. So the formula for time is distance divided by speed. And similarly, in the third one, if you want to know the formula for speed, speed is colored, it's highlighted. And if you highlight speed, what are you left with? You're left with distance divided by time. So hence the three formulae. Distance is speed into time. Time is equals to distance divided by speed. And speed is distance divided by time. So instead of remembering all these three formulas, if you just remember that triangle, from that triangle you can derive all these three formulae. Let us then again see what are the units of speed and also the concept of average speed. So as we saw, speed is the distance covered per unit time. It's a scalar quantity, means it doesn't require any direction, and is measured in meters per second or kilometers per hour. Okay, it's written etc. It can also be measured in miles per hour. But as of now, for your level, you have to remember that the units of speed are meter per second or kilometer per hour. And the formula, we already saw it, that formula for speed is distance divided by time, where distance is in meters. If time is in seconds, the units for speed will be meter per second. Now consider there are 4 vehicles, and 4 vehicles are covering different distances in different time. So if you want to find the speed of those vehicles, then the concept of average speed comes into picture. So here we take an average speed covered by all 3 or 5 vehicles, many other vehicles you want to. So what you have to do is, you have to calculate their distances. You have to measure their distances covered. You have to see the distance, how much they have covered, and you have to add all the distances. That will give you the total distance. And then you have to take into consideration the time taken by those vehicles to cover that particular distance, and all those times you have to add, and that will give you total time. And then in order to find average speed, you have to use the formula average speed is equals to total distance upon total time. Again, the units remain the same, that is average speed units meter per second. Now just to highlight more towards what are scalar quantities and what are vector quantities, and also what are the different examples, let us take a glance to this image. Scalars, they have magnitude. Now what do you mean by magnitude here? Magnitude means size. They have a particular size. Like let's take one example from this list, like time. Time, it's given in minutes or seconds or hours. So it just has its size with it, that is magnitude with it, but no direction. So if I ask you what's the time, you will just say, let's say you will just say it's 4 p.m. You won't specify any direction, 4 p.m. to the north, to east, to my right, to my left. No, you don't need any direction to tell the time. Hence, time is a scalar quantity. So, scalar quantities, they just have the magnitude, but they don't need any direction. And the list of scalar quantities are distance, speed, mass, energy, density, power, length, area, volume, time, temperature, and work. So these are the examples of scalar quantities. While vector quantities, they have magnitude as well as direction. And they are displacement, velocity, weight, acceleration, force, impulse, pressure, momentum, gravity, and drag. Let me take an example from here. Okay, let me give you an example. Let's take an example of displacement. Okay, suppose we are in a class and if I tell a student to shift the chair, okay, if I call a student and if I tell that student, come on, shift this chair, the student must be wondering, okay, of course, he will apply some force to the chair in order to move that chair, but then that student will ask me, ma'am, where to shift the chair, whether to the right, to the left, or in front or behind. So here direction is very important when displacement takes place. Okay, so this was an example of a vector quantity where along with magnitude direction is also necessary. So this is the major difference between scalar quantity and vector quantity. That is, scalars don't need direction, but the vector quantities, they need direction. Thank you.